Physics needs math. Without math, there will be no proofs. And theoretical physics is one of the most subjects that require math. So prepare your papers and pens and let's start. Theoretical physics requires, other than mastering high school algebra, geometry, and trigonometry, more advanced math. And one of the most important subjects is linear algebra. We all know what's a linear algebra. It's very important for quantum mechanics and quantum computing, where you deal with for vectors, matrix, complex numbers, eigenvectors, and so more. Usually linear algebra is given after calculus 2 and before calculus 3, but I'm gonna tell you that linear algebra is not hard anymore, but it requires some concentration. Second, we need functional analysis. Functional analysis is a study of what we can say topological objects that act in a certain way, and it's the study of spaces such as the Hilbert spaces and also using linear operators. Third, and for calculus, you have to understand it all, practice it all, from the differential equations to partial differential equations, also the multivariable calculus. Well, we use the separation of variables in the Schrodinger's equation. Not only you have to study tensor calculus. Vectors and tensors are very important for the theory of general relativity. Here you can see in the picture the fourth, and for the very advanced, topology and differential geometry. If you are studying string theory or deep brains or whatever, you find yourself in very need for topology to describe the brains and the topological shapes, also the theory of quantum field. You're gonna use it for objects that twist, curve, and for four-dimensional objects. Where about the differential geometry, it's one of my favorite fields. It is a bit similar to topology. It's the study of geometrical objects that have some curves and manifolds and higher dimensional analogues of surfaces.